Now in this video we are going to discuss about 11th standard computer science chapter 4 theoretical concepts of operating system part 1. So in the previous class we discussed about what is meant by software and what are the different types of softwares. There are two different kinds of software, application software and system software. The operating system comes under the system software. Okay, now in this class we are going to discuss about what are the key features of operating systems. Features of the operating system, that is user interface, file management, memory management, fault tolerance, process management and security management. Okay, so in the previous video we discussed about what is mean by user interface, how to create a user interface, what are the points you must remember when creating the user interface. Okay, now in this video we are going to discuss about file management and memory management. Memory management. Okay, you know already what is meant by memory. The word memory is used to mention the primary memory, that is main memory stored in your computers. Okay, memory is the place where you have to store the data. Memory management is the process of controlling and coordinating computers main memory and assigning memory block, that is a space, to various running programs to optimize overall computer performance. So the main memory can take data at the time of processing. So when the computer is ready to process, when the CPU can do the process, at that time only the main memory take the data for processing. Okay, so memory management is used to assign the memory space for that particular process, which process is needed. That process, the memory management assign the memory space for that particular data. The memory management involves the allocation of specific memory blocks to individual programs based on user demands. So through this memory management, it also allocates the memory blocks to the individual programs, that is your user programs. User demands, based on the user requirements, they will allocate the memory space to store the file. At the application level, memory management ensures the availability of adequate memory for each running program at all times. So we already know main memory is having less memory space. So based on that allocation, based on that space, the space are allocated for the applications level also. Okay, so adequate memory for each running program at all times. So for each and every time the program is going to run means the content can be stored in the main memory. The objective of memory management process is to improve both the utilization of the CPU and the speed of the computer's response to its user via main memory. We already learned response time or access time. What is the meaning of response time? So when you give the read or write request, how fast the content can be read or how fast the content can be, how the character can be written is known as the response time. How fast it gives response to the read or write operation is known as a response time. So the memory management process is used to improve the utilization of the CPU. So processing speed can be increased as well as speed of the computer response is also increased through this memory management. For these reasons, the computers must keep several programs in main memory that associates with many different memory management scheme. So some of the programs is permanently stored in the main memory that can be associated with the many different memory management schemes. The operating system is responsible for the following activities in connecting with memory management. So what are the processes the operating system can do for memory management is, the first one is keeping track of which portion of memory are currently being used and who is using them. So the operating system maintains the details about the memory space, which portion of the memory is used, which portion of the memory is empty, which that memory space is used by which process. Okay, all these details are maintained by the operating system. determining which process or parts of process and data to move in and out of memory. So the OS can determine which process and data to move in and out of memory. We know at the time of processing, the processor can take data from the main memory. Okay, so the OS can maintain the data as well as processor, which data is moving to the process, which data is processed, and again it returned to the output devices. Okay, all these details are maintained. Allocation and deallocations of memory blocks as needed by the program in main memory, garbage collections. Okay, so the allocation and deallocation is also done by the OS. So when the processor is ready to work, the allocations, memory space allocated and the memory space are deleted with the by only the operating systems. Okay, that is a garbage collection. Garbage collection is nothing but the empty unwanted details. Okay, so memory management. Now you can see the diagram about memory management. User programs, user interface, system calls, file management, memory management, process management, network management, power management, hardware operating system. So the operating system is used to manage all these things. Memory management means it allocate the space for programs. When that programs gets executed, okay, at the processing time, the memory space is allocated to the particular process, as well as the operating system maintain the detail which part of the memory is used and which part of the memory is empty, and which part of the memory is used by which processor. All these details are maintained by the OS. Okay, so the memory can be managed effectively, then only you can able to speed up the process of CPU, as well as it is used to speed the response time also. Okay, so that is memory management. So now you see about process management. Process management is function that includes creating and deleting process and providing mechanism for process to communicate and synchronize with each other. So process management is used to provide a schedule. If for example at the same time you are giving more requests to the computer. If for example I want to take 10 print, okay, so for I will give print command continuously. Okay, so I select the pages and then I will give a command print. At the same time I will send 10 print command, means the system can decide which one they have to take it first. Okay, so for that the processing schedule can be done with the help of this process management. Which process can be done first, which one is last. So this process management can be done by using several different kinds of algorithms. Okay, so based on that algorithm, the system can decide which process they want to do it first, which one is the next, and so on. Okay, so that type of process management, the type of scheduling the process is known as process management. A process is the unit of work in your computer. Okay, so a process is the unit of work. If for example, a simple example, when your students get assignment from the teacher, okay, the same time all the teachers, all the 5 subject teachers are giving assignment to the student. How the students can perform the assignment based on the priority of that assignment. So which subject they want to complete it first, which one he feel easy or which one he feel hard, depending upon the student, they will complete all the 5 subject assignments based on their interest. Okay, some students are finishing Tamil, English, Maths, Physics, Chemistry, Computer Science, like that. Some students are doing Computer Science, Chemistry, Physics, like that. Okay, so all the students are ready to complete all the assignment, but they have to prepare some separate schedule. The finishing assignment schedule is differ for each and everyone depending upon their interest. Okay, the same way here, when we send request to the computer, process request, all the jobs are completed. Okay, all the problems are solved. How it can be solved? Based on the schedule of the work. Okay, a word processing program being run by an individual user on a computer is a process. A system task such as sending output to a printer or screen can also be called as a process. Okay, so here one example is given. What is mean by process? Means when the system send a request to the output, okay, output to a printer or screen, that also is known as the one of the process. Okay, a computer consists of a collection of processes. They are classified as two categories. So all the process can be categorized into two types. Operating system process, which is executed by the system code. User process, which is executed by the user code. Okay, so when we switch on the system, automatically the booting softwares are loaded in your computer and your computer is ready to work. Okay, so this process is automatically done by the OS. Okay, so this kind of process is known as executed by the system code. And then if you give print command and you take the printout, or if you give command to display the message on the monitor, so these are all the commands, these are all the requests given by the user. Okay, so we say this commands are known as the user process. Okay, this type of job is known as the user process. So the process can be classified into operating system process and a user process. Operating system process are done by the system code. User process, which is executed by the user code. Okay, all this process can potentially execute concurrently on a single CPU. So all this process are run where all this process is done by the central processing unit, CPU. A process needs certain resources include CPU time, memory, files and IO devices to finish its task. Okay, so a process need what are the things are needed to complete a process? It need a CPU time, memory, files and IO devices to finish its task. So we already know memory is used to store the content, files are used to save the content permanently, and IO devices, input and output devices, all these are packed together to complete a process. Okay, so if you give request to print and take the printout, this is also one kind of process. Okay, this process is known as a user process. Okay, the operating system is responsible for the following activities associated with the process management: scheduling process and threads on the CPUs. That is, scheduling means before going to process the job, they first prepare one schedule. Which one can take it first? Which job can be processed first? Okay, creating and deleting both user and system process. After the process is over, the process can delete from the central processing unit. Suspending and resuming process. So if the process get some request, they wait for some input, then that process is suspended and it move on to the next process. Providing mechanism for process synchronization. So it gives the mechanism for process synchronization, providing mechanism for process communications also. Okay, it also provide a mechanism for communication. So each process is have interaction between the others, then only they can able to move one process to another process. So process management, now you can see one diagram for process management. Here some process is sent to your computer, it is ready to run. Okay, so run, ready, blocked, suspended, ready, suspended. Okay, so once a process is ready, it create a process and send to the ready. So the ready process is going to run. Okay, run with your CPU. If the process is completed, then the system can terminate. Otherwise, if the process requires some inputs, then that process is blacked, and then black suspended, that they get all the inputs, then the black suspended and it is ready to process. Okay, again the cycle is ready to go for processing unit and get the process. Okay, so this cycling can be done in the process management. The following algorithms are mainly used to allocate the job to the processor. So what are the algorithms are used? So these algorithms are very important. 5 mark as well as this questions can be asked in 3 mark questions also. Okay. So FIFO, first in first out. SJF, shortest job first, and round robin and based on priority. Okay, so these four algorithms are used for scheduling purpose. Okay, FIFO, what is the expansion of FIFO? First in first out, or you can also say it as first come first serve. And then SJF, shortest job first, and then round robin method based on priority. Okay, so now you can say this FIFO. This algorithm is based on the queuing techniques. That is, when you standing on the queue, how the corrections can be done. Who is standing in the queue first, that student get correction first. Okay, and then the next one like that. The process can be executed in the order in which order they get inside of the CPU. The same order the process can be processed and sent out to the CPU. So say here, assume that a student is standing in a queue to get grade sheet from his teacher. Okay, so the student standing in the queue, they want to get a rank out from the teacher. Okay, so the other student who stands first in the queue gets his grade sheet first and leaves from the queue. So followed by the next student in the queue gets it collected and so on. Okay, so the one after another, in which order the students are standing, the same order they are getting the rank order. If the note correction, if the teacher wants to ask all of you stand and submit your note for correction, so how the students are submitting their note? Who standing in the queue first, that students is submitting their note first, and then next one. So one after another in the sequence order, in which order they are standing, that same order they are submitting the notebook. The same way in which order the process enter into the CPU, the same order the process can be executed. That is known as FIFO, first in first out. Okay, this is the basic logic of the FIFO algorithm. Technically, the process that enters the queue first is executed first by the CPU. So, what is the concept here? Which process is entered first? That process is executed first by the CPU, followed by the next and so on. The process are executed in the order of the queue. So now you can see one example of this. Here we insert the element A in that tray, okay, and then we include a second element B. If you want to take the element from this tray, the first element, which one we have to put in the tray first, that is come out first, and then we take the second element. Okay, that is first in first out. Which element is going first in this stack? A. Okay, A comes out, and then this Q, which one is the next element? B. So the B element can be comes next. Okay, so in which order we are posting the element in this Q, that same order it comes out. So this is the example of your first in first out algorithm. Next we see about SJF, shortest job first scheduling algorithm. This algorithm works based on the size of the job. So which job is having minimum size, that job can be processed first, and then you have to do the next one. Okay, so for example, when the students getting assignment from the student from the teacher, they just look at the assignment, which one is having small size, that assignment can be processed first. The same way in this SJF algorithm, the job is selected based on the size. Which job is having minimum size, that file can be processed first. Okay, now you can see the example here. Consider two jobs A and B. A equal to 6 kilobyte and B equal to 9 kilobytes. So both the jobs A and B is having the memory size kilobytes. Okay, A is having small memory size, that is 6 kilobytes, and job B is having 9 kilobytes. Okay, which one is processed first? It processed the job A first. So first the job A will be assigned and the job B gets its turn. So this is known as the shortest job first algorithm. Now you can see this example here. The four processes given: P1, P2, P3, P4. Each process duration time is also given. Okay, 6, 8, 7, 3 order. So in which order they enter into the CPU, that order is also given. P1 process is entered into the CPU first. P2 process is entered to the CPU second. And then P3 is entered the CPU third. And then P4 it comes in the fourth place. Okay, arrival time. Now you can see which one is processed first. Which job comes first, that will be here size. We see the size of the file. Here which one is minimum size? P4. So P4 can be processed first. So the waiting time of P4 is 0. Okay. So this process is not waiting. When you enter into the CPU, it gets executed. And then which one is the next one? The processor P1 is having the minimum size. P1 size is 6. So the second job P1 is completed next. Okay, that is P1 waiting time is 3. That is P1 is wait for 3 seconds. After completing the process P4, the P1 is enter into the CPU and that process can be finished. After P1 process is finished, which one is minimum one? Next minimum P3 job. Okay, so P3 waiting time is 9 seconds. That is after completing P4 and P1, P3 can be executed. Okay, so it takes P3 waiting time is 9 minutes. And then the last process, that is P2 can be processed. So the P2 waiting time is 16 minutes, 16 seconds. Okay, so the total processing time, how much of time? 16 plus 9 plus 3. Okay, so how much is 24? The average waiting time is 0 plus 3 plus 9 plus 16 divided by 4 is equal to 7. Okay, so the total time, what is the total time here? Here we can see what is the total time is taken to process. You must add this value: 6 plus 8 plus 7 plus 3. Okay, 10, 10 plus 8, 18, 18 plus 16, 24. So the total time for process execution is 3 plus 6 plus 7 plus 8. So totally we get 24. Okay, the total average time, waiting average time is 0 plus 3 plus 9 plus 16 divided by 4 is equal to 7. Is it clear, ma? So total execution time, you must add this processing duration time. Okay, the average waiting time, you have to add this average waiting time available here. Okay, 0 plus 3 plus 9 plus 16 divided by 4 is equal to 7. So this is the average waiting time. Now you can say about round robin schedule. The round robin, in the name itself you can able to identify round robin. That is, this algorithm worked based on the circular method. Okay, so the round robin scheduling algorithm is designed especially for time sharing system. So jobs are assigned and the processor time is in a circular method. So each job is having some specific time. Okay, the job can be processed on that time only. If the time is end, the job automatically comes out of the CPU. Okay, for example, take 3 jobs A, B, C. First, the job A is assigned to CPU, then job B and job C, and then again A, B and C and so on. Now you can see the example of round robin method. Okay, here also we are taking 4 processor. That is 4 process P1, P2, P3, P4. Their burst time is 21 seconds, 3 seconds, 6 seconds and then 2 seconds. So the average waiting time will be 11 minutes. Okay. So first the P1 process is processed. After the 5 seconds, next it will take the P2 process. So P2 totally having only 3 seconds. So 3 seconds P2 process is completed, means again it takes the P3. So each process I have to allocate a time for this each and every process. Based on that time, the process can be executed. If for example, I will say one more example, A, B, C, there are three processes. Okay, consider totally three processes there, A, B, C. The process A is having 10 seconds, and then B is need 15 seconds to complete. C is need 20 seconds to complete the process. Okay, so but the time allocation is 5 seconds for each process. Once the job A enter into the CPU, it processes first 5 seconds. After the 5 seconds is over, the job A is exit from the CPU, and again job B inside of the CPU. After 5 minutes, 5 seconds, again the job B will be exit, and then C will be worked. Okay, so this type of time allotment and processing the jobs is known as the round robin technique. Okay, so after first round is over, and then again it takes the same process. So A process is totally having 10 seconds. Okay, the second round again 5 minutes is allocated for A process. So the A process is completed, so A process is removed from the group. Okay, and then again B and C alone is there, so they spend 5 minutes for B and C. After completing this one, they come out of the processor. Okay, that is known as round robin method. Now you can see about the next one, that is the given job process is assigned based on, here next we see about based on priority. The given job, so based on the hierarchy of the process, which one is coming first, which one is having higher preference, that process can be processed first. Okay, now you can see the definition about based on priority. The given job is assigned based on priority. The job which has higher priority is more important than other jobs. Take two jobs A and B. Let the priority of A be 5 and priority B be 7. The job B is assigned to the process before job A. Okay, now you can see here we are taking two process, that is two jobs A and B. The priority of A is 5 and then B is 7. Okay, which one is having maximum priority? 7, B. Okay, so the process B is processed first, and then it takes the A process. Okay, so this type of scheduling is known as based on priority. Okay, these are the different process management algorithms. Okay, based on this algorithms, the CPU prepare a schedule to process the jobs. Okay, so what are the algorithms? FIFO, first in first out. SJF, shortest job first, and then round robin method based on priority. Okay, okay students, thank you. In the next class we discuss about the next concept. Okay.